So welcome back on board, Bridget. So this is number 3 in my series on how to install electrical wiring and rewire your boat. This one is going to talk about the subpanels. A great beauty of having what we call a distributed panel system is that rather than taking a really big wire to a panel by the chart table and then everything feeds off there, distributed panels means that there is no one central location. If you remember from the first one, I have a hub in the electronics cupboard which has the high power fuses in, and each of those feeds a panel. There's the chart table panel, but also several others. You can actually fit as many sub-panels as you like. They are basically just a fuse block or a switch panel. You feed them with one power wire from your main distribution block, goes to the sub-panel, and then you can wire in whatever you need to on that. Okay, so on this boat I have 4. I've got my navigation panel, which has got all the instruments and the stuff that I want to switch on and off quite regularly. Things like the inverter, the little inverter, the water pump, those sorts of things. So I want to be able to conveniently switch on and off. I've then got my bilge pump panel, which could actually run any other machinery. In my case, it is just running bilge pumps. I have quite a lot of them. That is midships, immediately next to where the bilge pumps are. That means that my wire run from that panel to the bilge pumps is minimised, which is a good thing. Reduces the voltage drop, makes your pumps work better. I don't fit switches into any of my bilge pumps. If the boat's in the water, then I want the bilge pumps on. If the boat's not in the water, it's lifted out and on the bank, I'm probably going to turn all of the power off. If for some reason, so for example I get a short on a pump, if I need to disable a pump for some reason, it's very easy to just pull the fuse out. You need a fuse in the system anyway. Every sub-panel must have a set of fuses, because you're going from a cable which can probably take 50 amps down to a cable which will only take 15 or 20. So you need a fuse to step down and protect the cable. My bilge pumps have a variety of fuses. The biggest one is fused at 25 amps, and that's linked up with I think it's 10 gauge wire. The smallest one, which is only a 500, only needs a 5 amp fuse. So you set the fuses down, remembering that you put a fuse in to protect the wire, not the component. If the component needs its own fuse, for example a radio, then they have a fuse in the wire that links directly to the radio with a small inline fuse in. That's protecting the radio. 99% of the time, if you're putting a fuse in, it's so that if you get a short in that circuit, the wire doesn't melt and catch fire. It's there to protect the wire, not what's on the end of it. Okay, so bilge pump panel. The other panels I've got, I have a panel in the engine room which runs all the stuff that's in the engine room, except for the light. One thing I'd like to do is to keep cabin or lights separate from other things. If something happens in the engine room, I may well want to pull the fuse and cut the power to all the machinery in the engine room. But I still want to be able to see what I'm doing, preferably not using head torch. So the light in the engine room, and yes, your engine room wants a light, unless it's one of these where you take a cover off and it's in the main cabin. If you've got an engine room, make sure you've got a light in it. Same with the anchor locker. If you've got spaces which you might need to access, put a light in, it makes life so much easier. Okay, so engine room panel, that feeds anything that's in the engine room. The other one I've got is the one outside, which I'll show you a bit later in the video, which runs all my navigation lights, because who wants to have to climb down into the cabin and go to the chart table because you've turned the motor on and you need to switch your steaming light on? You want those sort of switches near the helm. That's where you're controlling the boat from. So think about what you want to do in the boat, what your electrics are doing, and where is the most convenient place to do that to minimise your wiring run and make it easy and convenient to get at stuff. So secondary panels. This is my bilge pump panel. So all of the bilge pumps run off this. I have a lot of bilge pumps. Effectively, this is your machinery panel. So anything that wouldn't always be on can connect into here. As you can see, that's there. Each of those circuits on a traditional system would need to run from the chart table navigation panel. Not only does that complicate things, it also means that you've got a lot longer cable runs. The heavy cable at the top here, this is a 50 amp cable that runs from my main distribution board, and then the small wires go straight down to the bilge pumps, which are only a couple of feet away. So I save a great deal of wire by doing it this way. Next one is the, sorry about the noise, they're moving a boat. The next one is the navigation lights. Why would you put your navigation light controls on the main panel by the chart table? If it's getting dusk and I want to turn the navigation lights on, I'm sat in the cockpit, I'm on watch. I don't want to go down below to do it. I want them in the cockpit. Okay, so this is now all the navigation lights on a panel in the cockpit, dead easy to use. Not only am I saving wire by only having to run the main cable from the battery to here, which is about 3 feet, I'm not running a cable all the way to the main chart table panel back to here. Yes, some of the wiring on here is quite long, so the ones on the mast have got to run through the boat and up the mast. So yeah, there is some quite long cables on here, but principally it's here because it's super convenient. When I want to turn a navigation light on, I can do. If I want to start the engine, I can quickly start the engine and I can flick the steaming light on at the same time. They're right next to each other. So the one thing that I didn't show you is there is also a small panel in the engine room. So all of my stuff in the engine room, pumps, those sorts of things, all run off a panel in the engine room. Again, means if I have a problem in the engine room, I can pull the fuse, isolate all the electronics in the engine room, the rest of the boat is still working. One of the big advantages of distributed panel is that a problem in one set of systems doesn't disable the entire boat. So you can have the bilge pumps on and all your navigation system off. You can turn off all the stuff in the engine room but still have cabin lights. In an emergency situation, that's actually really useful. The other one I've got, which you might call a sub panel, is this one at the back behind the chart table panel. So what I've done here is this is all my cabin lights. It's much easier to run those off a separate fuse block. That makes it a sub panel. I'm on LED lights. I think my total draw, if I turn every light on in the boat, I draw something like an amp. So it's a tiny amount of current. So rather than run the main wire back to the main distribution block. What I've done here is simply run this off the chart table panel. So on the main panel I've got this one, which is cabin lights, which turns on the power for those lighting circuits. Again, if I needed to work on a light circuit, I can just pull whichever fuse and disable those lights without disabling all the rest. So yeah, you can be quite creative with your sub panels. Okay, so that goes through all the sub panels. The next video is going to be on the navigation system. How to install the computers, what nav gear to install. My goal with the nav system was to install a full comprehensive navigation system for less than $3,000, and I've got a chart table display which is 14-inch. Price up a 14-inch chart plotter, you're probably close to your $3,000 just with that one piece.